Hey guys, welcome to Wonders of Calculus, and this is part 2 of derivatives. So last time I gave you guys the limit definition of a derivative, but this time I'm just going to give you all the derivative rules. So the first one is the most common one, the power rule. So what is the power rule? Basically, if you have a function where it's just x to the n power, then the derivative of that, so derivative with respect to x of x to the n is equal to n times x to the n minus 1. So basically, what happens is you you put the n down here, and then you just subtract 1 from it. And after doing that, it brings you to this. So yeah, that's basically the power rule. So let me give you guys an example. So if we have x to the 2, right? Then we take the derivative of that, which is going to be 2x. Simple, right? Okay, let's move on. The next one is the product rule. Oops. The product rule. And so basically, what this is that if you're trying to find the derivative of, let's say, two functions that are being multiplied with each other, you basically, the result is going to be f prime of x times, oops, sorry guys, times g of x plus g prime of x times f of x. Okay. So yeah. So let me give you guys an example of this. So if we have, let's say, a function of x to the fifth plus 1 times x to the second, right? And if we want the derivative of this, then it's going to be x to the 4 times x squared plus 2x times x to the fifth plus 1. Okay? And, okay, so let's simplify this. So this is going to be 5x to the 6 plus 2x to the 6 plus 2x. And so this should give us 7x to the 6 plus 2x. And so the thing is, you can also just multiply these together to give you x to the 7 plus x squared. And then if you just take the derivative of them, you can take the derivative of them separately because that's another rule of the derivative. So this is basically equal to the derivative of x to the 7 plus derivative of x to the second. And this is equal to 7x to the 6 plus 2x. See? So this kind of just shows that the product rule and the power rule work with each other, which means that they are both true. Okay, let's move on. So the next one is going to be the quotient rule. So basically, if you want to take the derivative of a function being divided by another function, then what you get is f prime of x. So the derivative of the top function multiplied by the bottom function minus the derivative of the bottom function multiplied by the top function divided by the bottom function squared. So, okay, let's do another quick example of this, and we're going to be using the same f of x and g of x. So what was it? the derivative of x to the fifth plus 1 over x squared, right? Yeah. So, okay, let's just take the derivative. So it's going to be 5x to the 4. Or actually, you know what? Yeah, we can just add it up. Because, yeah, basically we're going to be multiplying it out and then minus. So, minus. Oh, my brain is not working. My brain is not working. 2x to the 6 minus 1 over x to the 4. Right? And so this is going to give us 3 3x to the 6 minus 1 over x to the 4. And this is going to give us 3x squared minus 1 over x to the 4. Yep, there we go. Simple as that. And if you wanted to double check, then we could do the derivative of x cubed plus 1 over x squared, right? Mm-mm-mm. Wait, guys, I did something wrong. I did something terribly wrong. Hold on. I did something terribly wrong. Oh, I multiplied this. This one was supposed to be minus 2x as well. And then once you get minus 2x, this is going to 2x minus 2, and then x to the 3. Yeah. Sorry, guys. Yeah, that was it. Forgot to multiply. So anyways, if you do this, you're going to get 3x squared minus 2 over x cubed. And so they're equal. So the next one we have is the chain rule. Basically, what the chain rule tells us is that if we want to take the derivative of the composite function, this is basically going to be giving us f prime of g of x times g prime of x. And also, I just want to let you know that if you were to expand it, such as this, you would basically be getting f prime of g, f prime of g of h of x times, hold on, my brain is not braining right now. Yeah, then you would take the derivative of this inside again, so it would be g prime of h of x, then multiplied by h prime of x. Yeah, so it can actually keep on expanding, so yeah, just saying. So yeah, that's basically it. Oh, and let me show you guys an example. So if you were to have x squared, okay, and you want to take the derivative of this, that's going to be the derivative of the outside first, so there's going to be 2, and then x squared, but then multiplied by the inside derivative of this, which is going to be giving you 4x to the third. And we also know that this is basically the derivative of x to the 4, which is equal to 4x to the 3. And so they're equal. Yep. And so that's pretty much it for the derivative rules. But I just want to show you guys some other things. So if you take the derivative of a constant, it's going to be 0. But why? So we know that a derivative is basically the rate of change, which is basically the slope, right? So if we have a constant such as 1, the slope on this is y equals 1 plus 0 times x. So the slope is basically 0 and thus 0. Okay. Also, if you take the derivative of a constant times a function, is going to be equal to the constant times the derivative of the function. Again, these are just rules. Again, derivative of f of x plus minus g of x is going to be derivative of f of x plus minus derivative of g of x. Okay? So yeah, those are some, I guess, important rules that really do make sense, but I just want to point them out. Okay guys, before we end off, I just want to quickly show you how to write the equation of a tangent line. So this is the Poinslow formula of a point, or I mean a line, is y minus y naught is equal to m, which is the slope of x minus x naught. Okay, so let's say that our function is x squared, right? Okay, so we're gonna want to find, let's say x is equal to 4, and we're gonna want to find this tangent line, okay? So basically, first we're gonna want to find the slope. We're actually first let's find the y value at this point. So basically we know that 4 squared is equal to 16, so this is equal to our y naught. And our x naught is obviously 4 because we have the 4 here. And so we're gonna want to find the slope at x is equal to 4. So the derivative of x squared while x is equal to 4 is going to be equal to 2x. And since x is equal to 4, then we have 8. So now we have y minus 16 is equal to 8, x minus 4. And so we're going to get y is equal to 8, x minus 16. And so basically this is our tangent line. You can graph it on Desmos and it is going to be correct. So thanks for watching, and until next time, peace out guys.